the differences in their blockage, the visual of the bumpers and the wavelength. Yep. Lambda is wavelength. Anybody else?
What is lambda?
Wavelength.
That is wavelength.
Lambda means wavelength. It's the symbol we use in physics to discuss wavelength. Anybody else? Next, there were three things you have to keep in mind. The atmosphere is increasingly complex. We're talking about the stratosphere that has been changing. There's plenty of oxygen up there, and Hofwinkel are special elements. Ozone's always being made. I told you it's kind of a back and forth street. Sun comes out, sun goes away, ozone formation and breakup. But humans have added ozone-depleting substances, which are any number of compounds. We keep making new ones, which are perfectly stable down here where we live. In the troposphere, please look up. None of these is really significant to you. I mean, toxic, you don't want to breathe it, but not unstable. Relatively common in your day-to-day life if you have air conditioning. The refrigerator and stuff. All of your electronics are made in factories that use these. They're relatively mundane chemicals. But a key fact that I have to remind you is things are really special when you get up high enough, because that's where the UVC is. And nothing is stable up there. There's no gases, which you can throw into the stratosphere and assume that they are stable there. Up high, because of UVC, everything falls apart. So these are perfectly fine around you and me, but when they get up there, they split off that single chlorine, and remember, it could be a single bromine as well.
What's the is it the CL or DR, or is it the,
What?
like, where is that arrow coming to?
The red one is pointing to the ozone-depleting substances, because in number 55, we'll talk about why those are less of a problem today. And something I gotta make sure that we all had from yesterday. Now I'm getting right to the end of yesterday's lecture, please look up. Chlorine, in the presence of ozone, holds on to oxygen just long enough to pass it on to another oxygen. And then it's single to keep doing that again. That's why I have an invisibility. Infinity. That was a straight up bumble. I was really trying. That was not an act. I really couldn't get the right word. And it's like I don't know infinity. Wow. Did I say invisibility?
Yeah.
I wanted that so bad. Come on, spring break. That's what it is.
So for the actual
Pretty much. The thing that's important to remember about the college board exams is that you do have the option of explaining chemistry in a narrative form on the free response. So you can write the words, single chlorine atom breaks up an ozone compound into oxygen gas and chlorine bonded oxygen. You can just write that words, or you can use the equation, but you have to know it. In the multiple choice, you would be shown the equations, but then I think you feel more comfortable recognizing them, right? So one way or another, you've got to know that it happens. Pretty much, if you can say it, you can write it. Let me try that again. If this room had a bunch of humans in sets of 3, I could act as a chlorine atom and tear off an oxygen, but lose him to another oxygen, and then tear up another one and lose her to another oxygen, and tear off another one until the entire room of O3s became O2s, and I'd still be around. You remember that from yesterday when we discussed that? This goes on forever and ever. Did I tell you what could actually stop this cycle? I mean, stand up for me. You can all imagine that I break up an ozone, but I lose the oxygen. And I break up an ozone, but she erases and she'll go to other oxygen. And I tear up another ozone and lose her to other oxygen. But what if I were to find another chlorine? Remember, we're all racists here, and I'm a racist. If I find a chlorine, I don't care about ozone anymore. I am finally complete. Right? You smell really good.
Yeah.
Thanks, bro. Okay. All of these are racists. They all have a preferential affinity to themselves. So, if that chlorine could make a stable bond with another chlorine, ozone could recover and that chlorine would be out of the game now. So as a matter of fact, the answer could theoretically be shooting a whole bunch of chlorine singles into the atmosphere and hoping that they find each other. But the ratio is the problem. Remember that the atmosphere is 20% oxygen. There's a lot of oxygen around. So chances are that a chlorine will bump into 1 trillion ozone molecules before bumping into another chlorine because of the ratio of their abundance. Does that make sense? If it's just a mean and me looking for each other at the Super Bowl and everything else is oxygen, we don't have good chances of finding each other. That's the ratio of ozone, oxygen, to chlorine. Yeah, bro.
So if we just stop chlorine output like entirely, it would just solve itself eventually.
That's right, and that's exactly what's happening. Let's skip ahead to number 45 real quick. These were regulated internationally in the early mid-1980s. By the way, Leah, I skipped your question.
Yeah.
Almost all of them, a large majority of them, yeah. Let me try to say that differently. When the global community saw that Australia was dying of skin cancer, most of us didn't care at all because it's just Australia. Nobody likes Australia. Everybody knows that, right? The planet hates Australia. Whacking kangaroos. They're all what?
They're all prisoners.
Yeah, exactly. Yeah. They're a bunch of like racist, drunk, mean people. But they make the best looking men. Like, all the hot actors are from Australia. That's a fact.
It's a straight up fact.
Science. No, really like it. There was a lot of years where Australia was dying of skin cancer, and they had like a national epidemic of like people with like explosive skin cancer rates. They went from like 1 in 100 to 1 in 50 to 1 in 20 to 1 in 10 to 1 in 4 or something. I mean, I don't remember the numbers, but it was like a dramatic rise in cancer rates. And the rest of the world's like, but then they detected a very small weakness in the ozone layer over the northern hemisphere where the important people live. And oh man, global response, 0 to 60. It literally took less than a year. It's pretty amazing. Like, first science, first conversation, first meeting, second meeting, global convention, ratified international treaty to regulate or ban ozone depleting substances that went into effect the next year. I hope you are all inspired. It is possible for the global community to take action on environmental issues if we want to. If you think about it, it's a pretty obvious one. Like, yes, we're all going to fry in outer space radiation unless we regulate the spray paint guy, the air conditioning guy, and the styrofoam guy, who don't really have big global lobbies. Yeah.
Even if we stopped our chlorine output or whatever that we're doing, there would still be the molecules within the ozone that still have enough to get rid of it.
Sooner or later, when Amin and I have charged our way through the Super Bowl and eaten up all the ozone, we'll eventually bump into each other. And then the Super Bowl audience goes back to being ozone over time. Don't forget that ozone's always being generated. Every day we're adding trillions of new molecules. You know, they're kind of in flux. And as the number of chlorines are 1 in a million, 1 in a million, 1 in a million, finding each other and making stable chlorine gas, Cl2, then like gradually the ozone depleters go away. I think it's important to point out that ozone proves it's possible to have international agreement on environmental issues. It also makes me really sad to realize that greenhouse gases, unlike ozone depleters, they are tied to every one of our favorite things. My fishing boat, my badass Tacoma, my air conditioning in the house. Well, I don't have it, but if I did, I would love it. My cheeseburgers. Everything that we want in modern civilization more or less causes climate change. And it includes the most powerful industries. You all realize that the energy sector is the most profitable industry in the history of money, right? Everybody knows that? More money was made by energy than ever money was made. And so I don't think we'll get to regulate it. These things were easy to regulate because, like, who cares? It's like, hey, spray paint guy, shut up, make different spray paint. And spray paint guy's like, okay, sure, I'll keep, thank you, making spray paint, thanks, okay. But the fossil fuel economy, they're like, we have government. And for all the years until this year, I used to say something. You want to know what I used to say? I used to say, it worked. Because up until last year, the ozone hole was recovering. Up until last year, ozone depleting substances were shrinking in the atmosphere. They were disappearing from the atmosphere. Up until last year, we were on the way to removing these from the atmosphere by not adding any more, and the ozone was recovering. But something really strange happened last year. Levels of ozone depleting substances in our atmosphere started to rise again, and the ozone hole started to grow again. For the first time in like 30 years. Anybody know why? Did I tell you something? Back in the early mid-1980s, people were like, who should we invite to the international treaty? All the countries that have a modern economy, all the countries that matter. The US, Scandinavia countries, Canada, European countries, a couple of the big countries in the Middle East. You know who was left out? the entire continent of Africa. China, who cares? A bunch of starving socialists. India, who cares? A couple dozen starving skinny people. All of a sudden, China's economy is like blowing up. Africa's economy is like blowing up. India's economy is like blowing up. And so they're making more styrofoam and more spray paint and more microchips than the developed world, and they never signed those treaties. So the growth of the developing economies has reinvigorated these emissions, and we have to have like a second round of meetings where we get them to sign on. We probably will. I think in the long term, this is one that we can manage. Does anybody want to ask anything about number 45, status today of the ozone issue? Okay. Number 43 might be very complicated. I'm not trying to make it complicated, but okay, so number 43. There's a few things I want you to keep in mind. I want to do these first, okay? First thing I want you to keep in mind is the map of the convection cells, this one. And I want everybody to consider that area at the top. Remember how there's different donuts and they're all driven by the rising air from the equator? Please tell me you remember this. It's been 2 weeks. Yes? A lot of kids are like, yeah.
I just have a question.
Yeah.
About
Yeah.
what is
The 3. Yeah.
what is particle seeding and nitric acid? What is seeding? The particles inside the clouds seed.
Oh yeah, I can show you. Nitric acid?
Yeah.
So when ice forms in a really cold atmosphere, a particulate, precipitation nuclei, what do you call it? So you make a drop of ice from starts to grow on something. So they don't necessarily sublimate from the air. They start to form onto a little particle of dust. And so if it's cold enough, all of the vapor starts to make ice crystals. And those ice crystals fall. Watch this, kids. Look. Consider that in this area, the top donut, you're getting up at the 60s and down at the pole. Look up there. You see that top one? If you could imagine, look at me. From all of the Earth around 60 degrees, which is like Canada, the North Atlantic, Scandinavia, Northern Europe, much of like Russia, Northern Mongolia, China, I don't know, North Pacific, all that stuff rises at 60 and then funnels toward the North Pole and then falls toward the Earth at the North Pole. Does that make sense? Do you see what I'm saying up there? That donut? We're all the down at the pole. That looks like this. It's called the polar vortex. Keep in mind also that there are extreme seasons at the poles. So when it's winter, it is dark for 30 days. And when it's summer, it is sunlight for 30 days. It's important that you remember that. Consider number 2. Remember how chlorine would stop if Jose found amine? When chlorine finds another chlorine? I know that this is just like totally random thing to cobble together, but hey, surprise! Also, chlorine, when it bonds to nitrogen oxides, it makes ClNO2, and that's super stable. If not, remember the infinity thing. So watch this. From the 60s there is always a supply of NOx coming into the North Pole. In the winter, it's dark and cold, and all the water is frozen as ice. And you'll remember that NOx plus water makes nitric acid. So, because it's all ice, nitric acid crystals are pulled down by gravity, and chlorine is left in the atmosphere to eat all the ozone. Whereas in summer, it's bright and relatively warm, and water stays in vapor form up high, so NOx is up there to bond with the chlorine and allow the ozone to recover. You could say that NOx is a bodyguard, offers protection for ozone. When it's cold and icy, the NOx is living as ice crystals on the ground. When it's warm and steamy, the NOx is up in the atmosphere to protect ozone. So that's like a pretty complicated explanation, to be honest. I never feel like my students walk away nailing this one. But there is often a question about seasonality in ozone. When the sun first comes out, it's after winter when there's no NOx in the atmosphere. So ozone hole expands in the spring because there's nothing up there to stop the chlorine. And the ozone hole recovers and fills in the summer when there's NOx still in the atmosphere. That is the entire, like if you can explain why springtime ozone hole grows, you better mean.
That's just because it's not a lot of.
That's right, the NOx has fallen in ice. Yeah.
So, not or chlorine bonds with NOx rather than ozone. Is that because it's anything like has two molecules rather than three? Or
There is no better way for me to explain to you why they bond than to just tell you it's almost as good as another chlorine. That ClNO2, that thing, is a really strong bond for chlorine. I can't, A, I don't remember the reason, B, I couldn't explain it anyway without talking real chemistry. But hey, I don't even remember. It is a really strong bond. That chlorine is not going to eat up any more ozone. That's not going to break up. You're not going to get a single chlorine out of that. Tim, you were going to ask a question.
Oh yeah, all the ozone or all the NOx is on the ground, and then it just doesn't fall. It's being sucked up from the 63.
It's being sucked up year round. It's a gas year round. But there's a thing about ice, which is gravity. Like particles of ice are just bigger, they're heavier. Right. It's cold enough that you build ice particles in the air and they just gravity down. So NOx is here and that's bad. Sad face. Here there's no ice, so there's nothing to pull it down. So the NOx is in the right, it's being delivered all the time. But when the sun is out, it can stay in the atmosphere, which protects ozone. What else? You remember the image of like how hard it is for me to find a mean in the Super Bowl, even if the whole Super Bowl is full of ozone? I went through all of that. Imagine if Jose enters the Super Bowl and they're like, well, we don't have any amine for you, but there's this other thing that's just as good. And Jose's like, okay, great. That's this. The chlorine bonds to the NOx and makes ClNO2, which is a super stable long-term bond, and so it's never going to get into the ozone again. You're right that you're looking at an acid there, nitric acid. I don't think it's exceptionally acidic, no. The majority of the water vapor that is donated to the poles comes off the oceans.
Thank you.
And so you dilute the oxides in man-made emissions pretty dramatically. By the time it gets up there, the ratio of oxides to water is pretty low. So the net acidity of that precipitation is not very significant. The last study goal that I want to talk about is number 46. I want everybody to play it safe. Just write down, never mention ozone and climate, never mention climate and ozone. Just that was your first warm-up of the unit. I want it to be the last thing you write in this homework. Don't try to explain any similarities. Yeah, they share ingredients like ozone and CFC, those ingredients, but water's everywhere. We're not going to confuse climate change and rain just because they both include water. So yeah, they have some of the similar ingredients, but as phenomena, they're separate. They're different parts of the atmosphere. I mean, there's water on a slip and slide. That doesn't mean that there's slip and slides in climate change. Like, yeah, they both share ozone, they both share chlorofluorocarbons, but please leave these things separate. Don't confuse climate change, which happens in these clouds, with ozone depletions that happens in that blue teardrop thing. Different layers, different phenomena. Please don't confuse them.
So is climate change and ozone depletion?
I'm sorry, say it again, please.
So there's climate change and then ozone depletion.
That's right, and those are two independent problems on our planet. Like, if you get shot and you have cancer, like, yeah, they're going to make each other worse, I guess, maybe, and I could probably explain how if I try long enough. But we just treat those as separate issues.